Hi everyone. Let's see today's problem. The LeetCode problem number 169, majority element. Okay, given an array nums of size n, return the majority element. Okay, the majority element is considered in this way, like the majority element is the element that appears more than n by 2 times, like which is the size of half of the size. Okay, you may assume that the majority element always exists in the array. Okay, the problem itself says the majority element always exists in the array. Let's take an example to explain. We have an array with elements 3, 2, 3. And the size of this element is like size of this array is like 1, 2, 3, which is n is equals to 3 here. If you see, the occurrence of 3 is 2 and the occurrence of 1 is 2 is 1. So if you see, is 2 occurrence of 3, like which is 2, is greater than n by 2? Is 2 greater than 1? Yes. So the majority element is considered as 3 over here. To solve this problem, we have three solutions over here. First one is the brute force, and second one is the better approach, and the third one is the optimal solution. Before jumping into the better approach and optimal solution, let me walk you through the brute force solution, just an overview of the brute force solution, how it will be working. Consider we have an array 3, 2, 3, right? So here I'll be fetching the first element of the array, which is 3. See, first I'll iterate the array, then inner iteration will be done. First I'll fetch the first element of the array, which is 3, then I'll iterate and compare with other elements and count the occurrence here. If you see, this is the first loop, like outer loop, first outer loop, then comparing with the other elements will take inner loop. So each comparing with each element here, then I'll increment this count. Then after the loop is being executed of the, like after the inner loop is being executed, then I'll just compare whether the count is greater than n by 2. If it is greater than n by 2, then I'll return the array of that particular element. So if you see the time complexity over here, we aren't taking any space complexity. So space complexity will be big of 1. If you see the outer loop, this, for fetching the first element, the outer loop takes big of n. And within the outer loop, there's one more inner loop, so which takes big of n. So total time complexity will be big of n into big of n will be big of n square. So which is in better. Okay. So we'll be moving with the better approach here. Now, just let me select the color of the pen. Yeah. Now, we'll take the same example, array of 3, 2, 3. In the brute force approach, the time complexity was like big of n square. We'll try to reduce this big of n square to big of n over here. So by using by using this time complexity to reduce big of n, we have to use an extra space. So the space complexity will be big of n here. So the extra space will be like hash map. We'll be taking hash map. As hash map contains key and value. In key, I'll be adding the element, and in the value it will be the occurrence of the element. Right. Let's say the first element is a 3. So by default, if 3 is occurred, so by default, the occurrence of 3 will be 1. Then similarly, the next element is 2 here. So the occurrence of the 2 is 1. And again, 3. Already 3 is present. So the occurrence will be updated to 2. If you see the final hash map, 3 is to 2, 2 is to 1. So which says 3 has 2 occurrence and 2 has 1 occurrence. Again, we'll be iterating one loop, like for match, like for checking whether the count is greater than, whether the occurrence of the element is greater than the length of the half of the array. So we'll traverse the loop like dot items, like hash map dot items. This items is a Python syntax to get key and value. To get key and value, if particular I dot value is greater than n by 2, like integer division of half of the array, if it's there, then return immediately. Return the key itself. So in this case, if you see is 2 greater than n by 2, yes, it is greater than 2 is greater than 1. So it will return the immediate key, which is 3. And now let's calculate the time complexity over here. If you see, we have taken extra space, which is big of n, and we have taken only one loop, one for loop to check whether the count is greater than half of the size of the array or not. So this is big of n. So space complexity and time complexity, but still we can manage to get the solution in big of 1 of space complexity and big of n in time complexity. Let's go to the optimal solution here. Okay. To solve this problem, like to solve this majority element, we have an algorithm called to solve this majority element. Okay, we have an algorithm called Bouré-Moore's algorithm. Okay, this algorithm is like especially voting your candidate. Like you have multiple candidates, let's say candidate A, candidate B, candidate C. You will be voting for each of them. For example, uh, in a village there are three people, and three people have voted for all the three candidates. In another village, they have voted for A and not for B and not for C. If you see the majority element is here is A, so A will be the majority element. So the algorithm works in the same way. For example, let's take we have an array 3, 2, 3. Right now, let's say I'll by default I'll just create a variable count with 0, and let's say I have a candidate, so that I have to return the candidate in this algorithm. Okay, I have to return which candidate has a majority votes. So I'll just iterate through the loop for this one for n in array. Okay, now let me check. If count is zero, if count is zero, then I'll assign the candidate. Okay, so the now the candidate will be n here. If candidate is equals to num, like the particular element, then I'll increment the count plus equals to 1, else I'll just decrement the count minus equals to 1. Okay, now if this is finished, like if the everything is finished, the loop condition, then I'll just return the candidate. Okay, let me show you an example. Let's say I have an 3 2 3 as an array, right? Initially count is 0 and candidate is also 0. It's like candidate is not assigned here. So if I iterate the array, the first element is n. Now check the condition. Is count equals to 0? Yes, count is equals to 0. Then I'll assign the candidate. Now the candidate is 3, right? Now check if candidate if candidate is equals to current element. Yes, candidate is 3 and 3 is equals to current element. So the count will be incremented. Count plus equals to 1, right? And else condition will not be running. Then it will move ahead to 2. Now check. Now count is incremented to 1. Is count equals to 0? No, it's not equals to 0. Now check whether candidate is 3. Now candidate is 3. Is 3 equals to 2? No, it is not. It is not true. So the count will be decremented. Count minus equals to 1. Again, count will be 0 here, as it will go inside the else condition, right? Now again, the next element is 3. Now check. If count is equals to 0, yes. Now the count is equals to 0. Now count is equals to 0. Then I'll assign the candidate again. Now the candidate will be the current element. What is the current element? 3 again. Now check. If is candidate equals to the current element, which is 3, yes, it is 3. So increment the count here. Count plus equals to 1. Right. Else condition, it will not execute as it was matched with the if condition. Now the loop is over. Now return the current candidate. What is the current candidate over here? 3. So 3 is the majority element. 3 is the majority element. Now let's calculate time complexity over here. We are not taking any extra space, so the space complexity will be big of 1. Sorry. If you check, this is running only one loop, so the time complexity is big of n. If you compare between the brute force approach, let's say this is brute force approach, this is better approach, this is optimal approach. Okay, space complexity, time complexity. Space complexity for the brute force approach was big of 1. We were not taking any extra space, and time complexity was big of n square. Okay, in better approach, we were taking a HashMap and extra space, which was big of n, and big of n as a time complexity. In optimal solution, we were taking space as big of 1 only, and time complexity as big of n. If you compare brute force approach, space complexity is good, and optimal approach, space complexity is good. Whereas brute force approach, time complexity is more than the better approach and optimal solution. It's like it's almost double over here. Big of n square, right? So big of n square is less than big of n. So this is the optimal approach. Let's go and see here. If you see, our algorithm was like Boremois algorithm. So your count will be equals to 0 and candidate will be 0 here. Then I have to iterate through the array for n in nums. If count is equals to 0, then I'll assign the candidate here. Right. If candidate is equals to current candidate, then I'll increment, else I'll decrement the count. Return candidate. See, the runtime is 3 ms and memory is almost optimized. If you want to say the space complexity and time complexity, you can here. If you see, therefore the time complexity is big of n and space complexity is big of 1.